So this is the first in a series of videos I will make, all to do with manipulating concentrations, volumes and amounts of material. Many students find it hard to grapple with or manipulate solution concentrations, but it's a key skill expected of chemistry graduates. So it is something you will need to master, as it will be necessary for labs, exams, tutorials and in your future employment. There are too many different tricks and methods that people try to learn. Things like C1V1 equals C2V2, triangle rules, dilution factor equations and so on. What I'm going to show you is that you need just one fact and some basic algebra, and you can avoid having to remember all those different things. So think about some of the units for concentration you know, like moles per litre, grams per kilogram, parts per million, or percentage volume. These units actually tell you the equation you need to remember. Remember the unit for speed, meters per second, is written as meters over seconds. To calculate speed, you divide the distance you've travelled by the time it took to travel that distance. So we write that equation as distance over time. So notice that the units of speed are meters over seconds, and to calculate the speed we divide the distance in meters by the time in seconds. So the units of speed are meters over seconds, and the calculation for speed is meters over seconds. Meaning that the units of speed are telling us not only the equation we need to use, but also the units we need for the components of that equation. This is true for all equations, so whilst we've worked it out for speed here, we can apply it to concentration easily. So as with speed, for concentration, if you know the units, then you already know the equation you need to calculate. So if your concentration is in moles per litre, then you need to divide the number of moles by the number of litres. Or if your concentration is in grams per kilogram, you need to divide the number of grams by the number of kilograms. So the formula of concentration will always be based on this general formula. The concentration of the solution will be related to the quantity of the solute divided by the quantity of the solvent. So imagine you have 5.2 litres of a 3.267 moles per litre solution. How many moles of the solute do you have? The concentration is in moles per litre, and that tells us to calculate that we need to divide the number of moles by the number of litres. We know the number of litres, and we know the concentration, so it's easy to see how we can calculate the number of moles. If we multiply both sides of the equation by the number of litres, we can cancel these two, leaving us with just the number of moles on this side. And so if we plug the numbers into that calculation, we can work out the answer. There were two units on this slide that we didn't cover before. Concentration measurements in both parts per million and percent are special because they actually have no units. The only way we can get this result is if the quantity of solute and the quantity of solvent in the calculation both have the same units, so when you do the maths, those units cancel, leaving the result with no units. So as a reminder, you can use the units of concentration to normally tell you the formula you need to do calculations involving concentrations. I always go back to moles per litre, or moles over litres. Then I use the formula for this to work out any other concentration equation I might need. In the other videos in this series, we will look at how this one formula can be used to solve most concentration related problems, covering things like the evil that is C1V1 equals C2V2, standard additions or dilution factors. Thanks for listening, and remember you can keep using this video as a reminder during the rest of your course.